Hey guys, so today we have a problem which involves U-substitution, and that is integration of e to the power of x over e to the power of x plus 1 dx, and that ranges from 0 to 1. So as usual, pause the video and give this problem a go. Alright, so hopefully you pause the video, and I'm going to go over the solution right now. So I gave you a little hint before, which was that you have to apply U substitution. So we know that we have to find a value of u. So let's say that u is equal to e to the power of x plus 1. So u equals e to the power of x plus 1. Now, since we have introduced our u, we also have to introduce a du, and that's how we're going to integrate it. So we can introduce a du by differentiating both sides, so we get du equals the derivative of e to the power of x is simply e to the power of x. Derivative of a constant is just 0, so then we just have du equals e to the power of x dx. And now you can see here we have a e to the power of x dx here and an e to the power of x dx here. So this is essentially just considered du. Now we can use that when we replace our values of u and du. So we know u is this part right here, so let's just rewrite this, 0 to 1 over u. And we know this is du, so we can just write du there, and then this is just going to be 1. Or you could also write it as this, but I personally like to write it like that. Now we just have to solve this integration. This integration of 1 over u is natural log of u, and that's true for anything. Like if it's 1 over x, 1 over t, it's always going to be natural log of x or natural log of t. Now, since in this problem we actually have 0 and 1, we actually have the region where we're going to find the area under the curve. So these are x values. But we converted this whole integrand into u. So we have to convert this x value into u, essentially. So what do I mean by that? Well, I mean that we have to replace this into here, because then we get the u value. So, for example, if we take this down here, let's replace x for 0, because we have a 0 in this bound. That's basically saying e to the power of 0 plus 1. This makes u equal to 2. Then we do the same thing for this one. We do u equals e to the power of 1 plus 1, which is simply u equals e plus 1. Now we have our upper bound and our lower bound. So let's also replace those. So our lower bound goes here, upper bound goes there. Let's do that. Lower bound is lower bound is simply 2. Upper bound is e plus 1. Then it's just a matter of replacing these in this natural log of u. So we get natural log of e plus 1 minus the natural log of 2. And now we don't need our plus c, that is not needed, because essentially we already found the area beneath the curve, and they actually gave us this 0 and this 1. So the only time you put a c is if they're asking you to find the overall function for that area. But since they already gave it to us, the 0 and the 1, the region, then we don't have to put a plus c. So that's essentially saying that if we have a graph, let me do it a little bit closer. If we have a graph like this, and let's just assume that this graph goes like that. It's probably not going to go like that, but for simplicity's sake, let's just say it goes like that. And then this is 0, and let's say this is 1. So this is the area beneath this whole curve. In other scenarios and other problems that we did on this channel, we had a graph like this. Something like this, and instead we just found the function of the area. We didn't find the exact area. This right here is the exact area. Other times we would get something in the terms of x, like e to the power of x plus 1. This would be the area function, like how you would calculate the area. But here we actually got the lower and the upper bounds, lower bound meaning 0, upper bound meaning 1. So that's why we do not need a C, and this is our final answer.